Ionic compounds usually form ionic structures. Now, for example, sodium chloride is an ionic compound. It forms an ionic structure that looks something like this. It's cubic in nature, but from this diagram we can't really see it clearly. But from the next video, you're going to see it very clearly. Let us head to the video. Here is a better diagram that represents sodium chloride. Now the gray spheres represent sodium ions, while the red spheres represent chloride ions, as you can see on the top right corner. I want us to focus on the gray spheres. Look at the one at the center of the cube, right in the middle. You'll find that each sodium, as you can see, is surrounded by 6 chloride ions. I have just faded the others so that you can be able to see it clearly. Now when we remove them completely, you can now see the entire structure. Now let us focus on the chloride ion. Now for us to do this, we need to extend the cube or the structure. And then we now focus on the chloride ion, which is represented by the red sphere at the center. You will also notice that it is surrounded by 6 sodium ions. And that is why you'll find that the structure of sodium chloride looks like a cube. When you look at salt crystals, they're like little cubes because this structure repeats itself over and over and over again with millions and millions of sodium and chloride ions. The structure is usually known as octahedral structure because it looks like 2 pyramids that have a square base put together, joined at the base, one facing up, another facing down, so we call it octahedral structure. Now the reason why we call structures from this kind of arrangement giant is because sodium ions and chloride ions would repeat themselves over and over again, combining in this structure to form what we call sodium chloride salt. Physical properties of ionic substances. Compounds that form ionic bonds have similar properties. To start with, when you take a teaspoonful or a spatula full of sodium chloride and add it in water and stir, you'll find that it dissolves in water. So we say that substances that have ionic structure are soluble in water. Solubility in water increases with temperature. For instance, if we add a lot of common salt, which is sodium chloride, in a glass of water and stir, some of it would not dissolve. But when we heat the glass of water, more and more of sodium chloride will dissolve. That property cuts across all ionic compounds. Melting and boiling point. Substances that have ionic structure have high melting and boiling points. This is because the ionic bonds are very strong. So you have strong ionic bonds that hold the ions together, meaning that would require a lot of energy for us to weaken those bonds or even break them in order for the substance to melt or boil. Electrical conductivity. Ionic substances such as sodium chloride, zinc chloride, magnesium fluoride, and others conduct electricity only in molten and solution forms, but do not conduct electricity in solid state. Why do you think this is so? Electrical conductivity is as a result of either movement of ions or movement of electrons. Now, in solid state, the ions are held together strongly by strong ionic bonds and cannot move. So, the compound cannot conduct electricity or even heat. But in molten state, when it is heated until it melts, the ions are free to move, and we say they are mobile ions. So they can move from one point to another and therefore enable them to conduct electricity. Similarly, in solution form, once the ionic compound dissolves in water, the ions become free to move from one point to another and they can conduct electricity.